sitting here directly. And as well, our special guest today from Infineon Technologies, Ariel Abam, please come here. He is the Vice President of Operations in the facility here in Mexico, and he has some special products to share and very good information. So I'll give the voice to Cristina Hermosillo to start the panel. Enjoy.
Thank you, Freddie. I'm going to read the introduction, and here it goes. The binational strategy for semiconductors. The semiconductor industry is leading the greatest period of progress in history, and our greatest potential still lies ahead. As the building blocks of technology, semiconductors will continue to enable the world's greatest breakthroughs, from aerospace and consumer electronics to energy and medicine. Entire industries will be transformed. They control the computers we use to conduct business, the phones and mobile devices we use to communicate, the cars and planes that get us from place to place. Certainly, semiconductors are an integral part of our lives. Through collaboration and effective government policies, Mexico has the potential to lead and add value to the semiconductor supply chain, as well as continue to create new jobs, drive economic growth, and help develop the technologies and workforce needed to build our future. So, the objective of our panel today is to discuss the actuals of the industry in general, what are the main drivers, what's there for the region, and which challenges we face as a megaregion. And also educate about what are the main focus of this industry and understand, the areas in which we are competitive and that favor us. Okay, so having said this, we're going to go ahead and let each panelist, introduce himself.
Thank you, Cristina. Good morning, everyone. My name is Lucas Coleman. I'm the director of World Trade Center San Diego. We are the international arm of the San Diego Regional EDC, our privately funded nonprofit in the San Diego region. About 180 of the largest companies in San Diego County invest in us to maximize economic prosperity and the global competitiveness of our economy. We also have about 20% of our funding comes from the public sector, so the Port Authority, the Airport Authority, the cities, the counties that are in San Diego. And so within the EDC, we also have a research team, domestic economic development team, marketing communications also. But for my team, we're really focused on three things. One is supporting exports out of the San Diego region. The second is to maximize foreign investment opportunities. And the third is to promote San Diego as a global hub for the competitive industries that we have in the region. So I'll leave it at that, and I'll pass it off to my colleague here.
Hi everybody, my name is Rodolfo Andrade, and I'm the Undersecretary of Economy and Innovation of Baja. And maybe I know almost all of you, but we've been working as a state together with Tijuana ADC and the other organizations to attract, retain, and generate more opportunities for everybody, improving the quality of life and focusing on more value-added opportunities for the state. And we'll talk a little bit more about that.
Good morning all, my name is Ariel Abam. I'm Vice President of Operations for Infineon in Mexico. We have a factory here in Tijuana that has been here for 50 years. That was part of acquisition from international rectifiers. International rectifiers is no longer in business, but under the Infineon name. We have been building these products and for the markets, automotive markets, medical device market, aerospace, and so on. Thank you very much.
Okay, so the panel is going to start with Ariel. Ariel, as Tijuana EDC, we get asked, when are you going to bring a semiconductor factory? And many people don't realize that, our state already has presence, in the sector, and that San Diego complements that, very well too, especially, with Qualcomm, which just recently gave an announcement. So we would like you to set the context, in order to understand what the actual process, involves, because there are several steps, required to produce a semiconductor. And also, if you could tell us, about your experience working at Infineon.
Sure. We have a video before that allow me to show you something. will stand up. I think it's going to be better. Basically, the semiconductor has two processes. One, we call it the wafer manufacturing. This is a wafer. This has hundreds and hundreds of transistors. You see it on the side. It's very thin. This is an 8-inch wafer. There are 8-inch, 12-inch, 6-inch. This process is the first process of the manufacturing of a semiconductor. This process is very highly sophisticated. It requires very specialized engineers and operators to get it done, and it's mostly automatic. These wafers are being built in countries like the United States, Europe, Germany. Infineon is a German company, so we have these manufacturing facilities in Germany and Austria, and also in Malaysia, but there are none in Mexico. The wafer manufacturing is extremely expensive, and just an expansion of recently announced by Infineon is around 2 billion euros. So that's the first process. Let me get the next one. It's going to be difficult to see. Very difficult. I'll put them on the table later on so you can see it. Now the second process, which is the assembly, test, and packing of the product itself. That's what we do in Mexico. All right. And I know, sorry when you are there, it's difficult to see, but I have it here. We have it here. So once we get the wafer is our raw material for our processes, and then we'll start, processing the final. We call it sewing. We cut it and we remove from that wafer a little chip, and then we solder it into a lead frame, a copper lead frame, and then we put some wires and so on, so that we can connect, finally, this chip to whatever circuit we will have. Normally, as a printed circuit board. So it is assembly, testing, and packing. That is what we do here in Tijuana. Skyworks is doing this in Mexicali, and Texas Instruments is doing it in Aguascalientes also. All right. Intel is in Guadalajara, but they are not doing manufacturing. I visited them. They are a validation and test house. They validate their designs, and they have this kind of manufacturing. The only manufacturing being done is in Tijuana, Mexicali, and Aguascalientes. From this, we will run a small video to make it more clear. I will not run the entire video. It is in YouTube, so you can find it under Infineon. All right. So we will run just the first portion and the last portion, and it will get a little bit more clear. And maybe if you have a question, by all means, I can answer. But hopefully, I explained it myself. All right.
All chips start out with a very simple raw material, sand. Sand is primarily made up of silicon dioxide, or silica. Silicon is the second most abundant element in the Earth's crust, but is only ever found as a compound with oxygen. Complex chemical and physical processes are required to ensure that silicon crystals meet the high production standards that apply to chips. To convert silica sand to silicon, the sand is combined with carbon and heated to an extremely high temperature to remove the oxygen. A number of other steps are required to create the finished product, namely an extremely pure monocrystalline silicon ingot called a boule, with only one impurity atom for every 10 million silicon atoms. Silicon boules are fabricated in a range of different diameters. The most common sizes are 150, 200, and 300 millimeters. Wafers with large diameters offer more space for chips. Extremely thin wafers are then cut from the silicon boules using a special sawing technique. These wafers are the basic building blocks for subsequent chip production. Silicon is...
We will jump to the end, but before we go there, so we just saw the first process. So you saw an ingot, then we slice it, and then we have this thin wafer that I showed, and then the process stops there. It's called the front end. That's what we call it, the front end. And then the second process is what we do in Tijuana, which is the back end. That's what we call it. It will not be shown here entirely since it's very tiny and it's difficult to see. But anyway, you will see, some explanation. And later on, as I said, you can touch a product or whatever is required. I'll keep it around. All right? So really good with things.
Will contain anything from several dozen to thousands of chips. Individual chips are usually sawed out of the wafer. The chips are not lined up flush with each other on the wafer because tiny parts of the wafer splinter off during the sawing process. A certain amount of space, known as the scribe line, is always left between the individual chips. Test structures are also integrated in the space between the chips and used to take measurements immediately after production. These test structures are destroyed during the sawing process. The size of the resulting chips typically varies between 1 square millimeter and a few square centimeters. The final stage of fabrication is assembly. Here, the individual chips are placed in a package and terminals are attached. The result is a finished semiconductor device, which can be mounted on circuit boards using different types of terminals. Over 1,000 connection contacts can be realized. Here are some examples of ready packaged semiconductor components. Special larger packages are used for power semiconductors intended for applications such as trains, electric cars, solar panels, and wind turbines. These power semiconductors are designed to switch electrical currents of up to several hundred amps and voltages that run into the thousands. Switching at this level generates high temperatures, and this heat has to be dissipated via cooling areas integrated into the packages. Here you can see some fully packaged power semiconductors. Cutting-edge technology is used for testing at every step in the fabrication process to ensure the highest quality levels in chip yield. Researchers and developers use scanning electron microscopes to repeatedly check the chips at different points in the production process. If we compare today's microelectronics with human hair, we can see just how small these devices are. The equipment used to check components and analyze defects is just as precise. These high levels of precision and quality are essential at every stage of the workflow, from the production of silicon boules through the cleaning room fabrication to quality control, in order to deliver these tiny building blocks that have such a big impact on our lives, today and in the future. After all, demand is rising for innovative semiconductor solutions that make life easier, safer, and greener. For technology that achieves more, consumes less, and is available to everyone.
Very well. I think the video is quite clear. The first process is quite complex, very chemical in nature, let's put it that way. The second process is more mechanical because it's an assembly process, very complex. The first process doesn't require much labor, but very specialized engineers, technicians. And the second process, of course, requires more labor because we need to run machines that are going to be doing the assembly. That's the opportunity we have, of course, in the second process called the backend. So it's front end and backend. Very well. Well, that's all I have, Cristina. I don't know if there's any questions or something.
We can leave the questions for the end, but thank you for setting the stage. And our next question is for Lucas and Rudy. And what is the main objective of the CHIPS and Science Act and the position of San Diego and Mexico on this strategy? So we'll let Lucas elaborate, on the CHIPS and Science Act. Give us your position, in regards to San Diego, and then we'll pass the microphone so that Rudy can elaborate, on Mexico's take on this.
So the CHIPS and Science Act, in its totality, is a $280 billion investment into scientific research that's meant to propel the United States into a leadership position in AI, robotics, quantum computing, semiconductors, and the like. And the $52 billion going to catalyzing the domestic chip industry is what gets the most attention, and rightfully so. It's a really big bet on being able to stimulate new clusters within the US. Within the $52 billion, we have $39 billion going directly to the construction of new fabs. Companies like Intel, TSMC will be big beneficiaries of that. The goal there is to stand up between 11 and 15 new fabs over the next several decades. And that's not fully going to be funded by this funding. It's really meant to incentivize in partnership with the private sector. We also have $11 billion that will be going to R&D that will allow the United States to compete in the most cutting-edge chips, which currently 90% of the most cutting-edge chips are produced on the island of Taiwan alone. So it's a huge vulnerability in the system, and I think it was evident during the pandemic when we had the supply chain shocks, where we got entire industries ground to a halt, like autos, because they couldn't get the right types of chips. And now, as we see global demand continuing to surge for the foreseeable future, it's also a huge national security threat. The Department of Defense requires 2 billion new semiconductor chips every single year. And a lot of them require, that entire supply chain goes through East Asia right now. And as you know, Taiwan is continually being threatened now and into the future by who the US sees as its primary geopolitical adversary, China. It just became a situation which is untenable. And so that's why we've seen across presidential administrations, several Congresses, bipartisan support from Democrats and Republicans. I think it's a testament to how monumental of a challenge this is. And it's essentially the only thing our government has really been able to agree on. And so legislation as big as this is going to have a lot of challenges that come with it. But I think for the San Diego region, along with Baja down here, we're going to see some opportunities too. I've been talking for a while, but I look forward to kind of talking about those opportunities and challenges. I'll pass things over to you.
Thank you, Gus and Ariel. First of all, when the CHIPS Act came into effect a little bit before, we wanted to understand where we stood as a state regarding semiconductors. Obviously, semiconductors is right now a very sexy name, but we have had semiconductors for 50 years. I mean, Rectificadores has been in Tijuana for almost 50 years. Skyworks has been in Japan for 52 years. So, and we've always seen them and we've interacted. We have friends that have worked in Rectificadores and Skyworks. And we really never understood what went on inside until it became obvious that we have to understand that. So first of all, as a state, we had to know where we stood in the whole scenario in Mexico. So we visited Texas Instruments in Aguascalientes, we visited Intel in Jalisco to understand what they were doing. Obviously, Intel in Jalisco has a very important R&D center, engineering center, and they generate quite a bit of patents for Intel. And we're working with them, with Palomino, which is the vice president there, and he really likes Baja. And we're working with him to see what he can do also in Baja. But there's certain, as Ariel mentioned very clearly, we are focusing back-end advanced packaging, the testing area, and that's where we have grown. And that's where the talent is. Because it's not a simple assembly, it's advanced assembly. It's really very unique in itself. So out of all the states of Mexico, Baja California is the only one that actually has a talent map for semiconductors. From high school up to PhD laboratories and research. And that was one of the reasons that Coleman saw Baja California as an option. It was not because of big incentives and so on. It was basically because the talent is there. And that is the main reason that Coleman is here. Coleman obviously is a fabless. What fabless means is they outsource all of the different processes that you saw in the video. And they do, everybody has a Snapdragon probably chip in their cell phones. And they're one of the biggest customers for TSMC in Phoenix. So when the new scenario came into effect where Intel, TSMC or bringing back or investing in big factories in Arizona. We're so close that we have to understand what we're going to be doing in this geopolitical, geoeconomic map of semiconductors. Nothing runs right now without semiconductors. So strategically, Baja California is working with the different semiconductor companies to see what else we could do and who else is interested. We're going to be next week in Washington with the SIA, Semiconductor Industry Association, which basically has as members the main semiconductor companies in the world. And not one of them did not want to assist them. All of them are going to be there to hear what Baja California is doing, and basically in the talent area. How can we sustain this growth with the talent that we have and what we have done really for 50 years? It's not new. So there's a lot of interest from other states, and you're going to hear the Sonora Plan and the federal government focusing on semiconductors to the transcontinental corridor, the Istmo, which is really extremely hard because there's nothing set up, especially and we've talked about this, Ariel and myself. It's a huge challenge, and the issue is that companies have to act now. It's not that they can wait 5, 10, or 50 years. The CHIP Act is going to come into effect, it's working, and they have to take advantage of that specific funding and other relative issues about logistics and so on now. So Baja California has a big advantage, and that's where we're aiming.
Yeah, and if I can just add one thing, I think this is such a competitive industry globally. Everyone recognizes the geopolitical importance and wants a domestic industry. This $52 billion for CHIPS Act is not going to be enough. We're going to need to see some self-sustaining dynamics to make the economics add up. And I think with all the investment going into fabs, it is important to talk about the back end, the testing, the packaging, the casing for the semiconductors that protect it from pollutants and then also allow it to connect onto other chips. Right now, Singapore is one of the leading hubs globally for packaging because of its proximity to Taiwan and South Korea, Japan, and China. And so, as we look to onshore some of these fabs to the United States, this is a tremendous opportunity for Mexico. And it's not even a low-cost thing. I mean, the packaging is somewhere we're seeing a lot of innovation on the back end for semiconductors because as we push against the edges of Moore's Law, and it's getting really difficult to design on the front end to make them faster. And so a lot of competitors are looking at how can we speed things up and make them more efficient on the back end, and so the packaging becomes really important. So talking with our friends at Qualcomm, who I'm sure you'll see next week, I mean, that's one area that they stress. This is a huge opportunity for the binational region to really compete. And like you said, talent is going to be one of the primary challenges for Mexico and regions around North America.
Okay, so you answered part of the next question, which is what are the opportunities that you foresee for the region? So we can start with Ariel now and work our way back to you.
Very well. It seems that, as Rudy mentioned, we already have a setup here for semiconductors. I think we have already experts working in our factories, and we have the universities now, focusing also on semiconductor topics. Then I believe that Baja California, especially, we're very well positioned to attract other companies. And so I would say I'm not trying, I'm working against myself, but the truth is, that I do believe this is a chance, this is a great opportunity. Other state has the not even Guadalajara, they don't have the manufacturing expertise, and it will take years for them to acquire it. It's not going to be overnight. Aguascalientes, of course, is also a possibility, but we are here. I think we can sustain operations like these back-end operations, testing, validation, prototyping, and those kind of operations here in Baja.
Regarding opportunities, I mentioned some right now, but when we talk to different companies that are already in Baja, Skyworks and Infineon, we basically did a double click regarding what they needed regarding new talent. What is it that needs to happen to sustain this growth? And the State University is opening up this August semiconductor engineering as an degree. So that's extremely important. And Ariel knows this, and also with Skyworks in Mexicali, what we did together with other electronic companies, because the basic for semiconductors is electronics. So what we did was a new advanced electronics and semiconductor certification, not only for the bachelor degree or engineering degrees, but also for mid-level, high school, and so on, technical degrees, so that people would, in a continuous education background, would get the traits to modify what they studied and be skilled to go into the semiconductor industry. So that's also fairly new. It's going to start coming into effect by the end of this year. So the semiconductor industry, it's not only infrastructure, but it's also huge in talent. So that is one of the things that we saw. Also, in the faces that are in the video, there's also substrates, which also is a unique process that is very few companies in the world, and Ariel can expand about this, but it's basically like chemical film that's put in the wafer, so that you can imprint or do other processes. But that's also a possibility, and it's a very value added, and very few companies in the world are involved in substrates. So that's another opportunity for
the binational region is a tremendous manufacturing hub, and we're particularly focused on medical device together. Those use chips. We talked about autos earlier, whereas the global demand for semiconductor chips increases 6% every year. It's double that in autos, about 12%. And so I think on its face, having a reliable source of chips close by is obviously a good thing in catalyzing other industries as well. We talked a little bit about the back end. I think on the front end too, as the U.S. is focused on more of the sexy big names when it comes to fabs and the things immediately surrounding that, I think on the front end there's a lot of opportunity for cooperation in rare earths and minerals, and then on the back end, like we said, with the testing and packaging. I think there are some challenges though. One of the stated goals of the Chips and Science Act is to achieve some geographic diversity within the United States for where these semiconductor hubs are. And in that regard, we talked about Qualcomm being in San Diego and having some excellence in the space. It puts us a little bit at a disadvantage. We've seen a lot of fabs being built in places like Arizona, Texas, Ohio, and that's on purpose. The math adds up a little bit there. But also when it comes to some of those R&D dollars, I've heard places like Indiana floated around. They want to see the inland parts of the United States also gain some expertise. So I think those are some headwinds that we're going to be facing, but there is money there that's going to go to San Diego institutions that are doing design semiconductors. And in that regard, the federal government is seeding some money for international partnerships, public-private partnerships. So I think there's a small opportunity there, but like I said, I think it's going to catalyze other industries in the economy in general of this binational region. And on the front end and on the back end of semiconductors, there will be tremendous opportunities for industrial growth here in Mexico.
Thank you, Lucas. Okay, so listening to you speak to the three of you, we get the idea, that we have to act quickly, but at the same time, that this is not an immediate process. So could you tell us, how you see the region in 5 years or 10 years, or give us an insight, on the time frame?
All right, I'll go first here. I think the immediate thing that we need to be thinking about is the talent question, because you can train we can throw all the money we want at this problem, and we intend to throw a lot of money at it. But if we don't have the people to work in these facilities and in the industry, then it's just not going to work out. And in that way, it's a global effort, and the United States wants to be engaging with its allies to create a more diversified supply chain that's safe. When it comes to the engineering talents, San Diego and Tijuana, this corridor has a lot of software engineering and programming talents. But from what I've heard from some of our friends at companies like Qualcomm, is that a lot of the semiconductor engineering talent is actually in places like Monterey, out east. And so getting that right mix of engineering talent is going to take time, but it's critical to the success of this entire initiative, this effort. And so I think that's something that we need to be thinking about. When it comes to the construction of these multi-billion-dollar fabs, it's going to take 10, 20 years to really see if the CHIPS and Science Act has been successful. But I think what we'd like to see in the next 5, 10 years is a lot of that talent and workforce being developed, and I think that's kind of the critical thing that I want to point out here. And like I said before, seeing some geographic diversity when those clusters are springing up.
Very well. I agree. The talent pool has to be there to be able to expand our operations, whatever that will be. And on top of that, we're going to need to understand that we have the right infrastructure so that we're able to place these large buildings, to move around raw materials, get spoiling back. And there are so many other things, from safety to just so many. So there are many factors that a company will take into consideration in order to establish a full-blown operation like the one we have. But on the other hand, also having already a successful factory somewhere, in this case in Tijuana or Mexicali, it is with being a large corporation, in Infineon we are 56,000 employees and we have 1,600 in Tijuana. So between a large corporation, we have been making a lot of noise. For Tijuana, we receive a lot of visitors. Governor was in Germany meeting some of our executives. So I think it is needed talent pool, infrastructure, and some other factors that will influence the decisions of companies to invest in Baja.
Well, what we see is companies being more stable in the processes. We know they're growing. We've talked to Ariel and Infineon, and we've talked to obviously Skyworks and Mexicali, and each of them have very specific infrastructure needs. Also, one of the needs is the sustainable energy, because all the clients regarding semiconductors are asking for sustainable energy at 2030, and that's something that we are addressing, where you can get the certified sustainable energy for the companies. And what we see is, as Lucas mentioned, and we already are addressing that, is having the right talent pool regarding technical level certification for semiconductors as well as engineering. So what we see is different incorporations of new processes of the current companies, as well as having in this case, qualitative testing, so doing testing in the facility, having more integration with Qualcomm and with other companies. But we have to work at this now. So that's something that we're addressing for the next 2 years.
Okay, so at this moment, we can open the microphone, in case anyone has questions for Ricardo.
Just Ariel had some more information, so
One more slide. This is a slide from the standard Infineon presentation you can find in our website. But it is a chart of the global semiconductor market. You see, 2018 to 2019, we have a hiccup there, 469 to 412. You remember that period. And then we go up, going up to 2022 with 573 billion US dollars, and then now we have a hiccup because there was too much inventory in the pipeline, so they are adjusting inventories. But then in 2024, the expectation is that this will continue growing. So you can see from the year 2000 to now, it's 3 times, and probably going to go faster growing since the electrification, digitalization, and all these technologies. Electric cars have so many chips, and that is what we're going to be seeing, as a trend in the following years. Thank you.
okay, so anybody has a question? I have one question here from somebody just sent it to me. I think this is for Rudy. How is Plan Sonora going to affect positively or negatively, and help the semiconductor industry in Mexico?
Well, Plan Sonora, I think, is a great effort by the federal government to focus on semiconductors, which is good. Now, what we have to do is, we're next to Sonora and we're ready. So anything that Sonora is advertising, we're next door, and companies really are pretty smart in the semiconductor industry. They know what they need, they know where it is. We were recently in Washington, D.C. a couple of months ago with the main universities, the main companies, and Canada, US, and Mexico secretary level people. And they were presenting, it was a 2-day event. It was a very, very precise 9 to 5 event. It was very, very, Infineon was there, and all the main companies were there. And, when you hear a lot of the states that are promoting, or they want to attract investment, it becomes repetitive. Everybody says, no, we can do everything for everybody. But the facts are that there are very few that can. So in our participation, we focus at what we already had, which is real. Infineon is real, Skyworks is real, Qualcomm is real. And it's not a dream. It's not that we're going to do this and 10 years from now it's going to happen. In this specific area, in this specific sector, Baja California has an advantage. And what we proposed was, why don't we stop wasting time, because companies don't have time. And why don't we focus on where companies can really go? So the proposal was, why don't we work, first of all, in a talent map of the 3 countries, so that they understand where they can fit, the companies, and also an infrastructure map of where they can fit the different processes. Because it doesn't make sense to waste time visiting 30 states or 20 states and having companies, going back and forth to the Istmo and so on, and wasting 6 months in and out. But they don't have that time. So it has to be very precise and controlled. So that is, to answer the question, Sonora has its benefits, but Baja California is ready.
Gustavo?
Good morning, Gustavo Alejandro, also with Baja, and Kingston Financial. Two questions. One is geopolitical. It's really addressed to every one of you. And I guess my question about that is, when are we going to wean ourselves off of Taiwan? When is that going to happen? Because 90% of all the front end here. How does that happen? And we're seeing the possibility over the next 10, 15 years of some kind of conflict in that part of the world. Hopefully it doesn't happen, but it seems to be pointing that way. And the second question is about the advanced chips and what's happened lately with that, and whether Baja California is prepared for that evolution into advanced chips. Does that pose any differences, or does it go with what we're doing? Is it coherent with what we're doing here?
Maybe I can answer the first part of that question. When will we be able to wean ourselves off of Taiwan? It's a very difficult question, because when it comes to the most cutting edge chips, we can't even do that in the United States now. Intel has fabs in the US, and they've not been able to achieve what TSMC has in the latest, most cutting edge chips. Like I said, 90% of those are currently produced in Taiwan. And so it's probably gonna have to be an all of the above solution. We're making investments in R&D to try to get there and to make it a possibility. But that's why it's important to be working through our alliance structure with reliable partners, particularly in North America, as we try and regionalize the supply chain back. Like I said, we won't know for 10, 20, 30 years how successful this effort really was when it comes to the CHIPS and Science Act. But as to when we'll be able to wean ourselves off of Taiwan, I'm not entirely sure that we can for a very long time. And also, it's not just Taiwan and the cutting edge chips. A lot of chips at the lower level, some people call them dumb chips, but really 1, 2 generations old. Some of that comes from China still too, to the United States. I mean, we're still sourcing from China as well. So like I said, it's a gradual movement to reshore and nearshore some of this and to geographically diversify. But I think East Asia is always, it's always going to be a vulnerable situation to an extent. We just want to try and minimize that to the extent that we can. Maybe.
Well, I think Ariel is the right person to answer. That's needed to get to some other ships. The only thing I know is exactly what you mentioned, because I think to get to the 3 nanoships is pretty tough. I think the smallest one in the US are at 7 nano or something like that, but it's still a long ways off what they're doing in time.
Very quick. Yeah, you're right. The advanced technologies require not only advanced equipment, but also require advanced know-how. And the know-how is the key here to be able to get into this competition of these super powerful chips. Nevertheless, we also have to think that most of our appliances, cars, and aircraft do not need such kind of advanced technology so far. And there are some applications that are very specific, maybe military grade or aerospace grade or some others, or some very thin, devices that require this kind of advanced chips. And so, yeah, it will take some time. I mean, we are in Infineon, of course. We are developing these kinds of very advanced technologies and are being built already. So some of them in Europe or Asia, not in Mexico. In Mexico, we have these standard chips that go into our cars, appliances. But nevertheless, if the trend will be, to move from Asia into America or Europe, then by all means, we can develop that capability even here in Tijuana. I don't see why not. While it is a back-end, not a front-end topic, but it can be done. We are unable to do it right now, but it is something that is feasible.
I have another question here. I think this goes to Lucas and Rudy directly. Is how San Diego and Baja California will work together to enhance this semiconductor industry, or the possibility to create a strategy together?
Well, we're doing it now. I mean, it's not something that how can we do it, it's how we're continuing to do it. Obviously, Coleman is an example, and obviously the market is an example. So, is in Tijuana and San Diego have been working together for a long time. Now, specifically, that we have, I mean, it's not by chance that the thing was here. It's also because San Diego's here. So it's really a very collaborative effort of what we're doing. I mean, we're now with Coleman. We're talking to Coleman every day as we speak. So. The interaction is continuous, so it's not like we're not starting.
Yeah, and just to add on that, I think continuing to invest in trade infrastructure at the border and to make that more seamless, and then like we talked about earlier, is when it comes to talent, to have our universities working together to develop the right types of engineering talent, and where the federal government is seeding some money for institutions in R&D, there may be opportunities for the premier universities on this side of the border to work collaboratively with schools like UC San Diego.
Well, I don't have any more questions myself. Does anybody have, another question? No? Nobody? No? No? Okay. Well.
Okay, so we're still kind of on time, and I would like to thank our panel participants. I think we learned a lot from you today, and Tijuana is going through a great moment. Last week we had a presentation from our developers who gave us information on the fact that we are building over 5 million square feet, in the city to receive, industries such as Ariel's, and we're also building infrastructure, in regards to energy, to receive these investments, and vacancy is practically at 1%. So I think we are at a moment, when we can gather together, as we're doing right now, and continue on our efforts, to build our own narrative as to where we're going to continue, to work on the semiconductor supply chain and industry. So thank you again, and count, with Tijuana EDC. All of you are our partners, and we feel, that is the way we should address this. Private enterprise, the industry, government, and our San Diego allies together, in order to make this region a better place for all of us. So thank you. Another question.
Yes, taking advantage of having Ariel here, and also you two. The first question for you will be, what are you guys doing in terms of upscaling and rescaling your talent for the new challenges that comes with the industry 4.0, and also how you in the Baja California state are working with universities in terms of developing this talent mapping for the region?
As Infineon has all these operations around the world, we are able to send our people to other operations so they are able to stay for specific trainings, equipment, processes, and that is the way we have been doing it. Also, we have hired foreign nationals that are working for us. Actually, we are getting 12 experts. We have a large project right now, and it's going to change much of our technology. It looks around the same, but it's not the same. And then these experts are going to be also training our people. People will go to Asia, come back, and then these experts will come and stay here for quite some time to stay with us, and together we will work to get this project going, for example. So that's the way we have been doing it right now. Although Rudy and I have been talking on how we're going to be developing, more skills and knowledge through master's degrees and some other topics, also how to train our technicians, etc. But yeah, we have been organically training our people and having foreign experts helping us also in specific cases like the one we have right now.
As I mentioned, we have, as we speak, already developed a talent map where the different expertise needed for the semiconductor industry has a specific source of school. If it's in a technical program, be it the HITI or any other schools, what they are teaching and who is hiring from them what type of expertise. So it's from high school level to technical professional level to engineering up to PhD. YSA has a semiconductor laboratory where PhD trained in semiconductors. That's all already set up since 15 years ago. And it's in Mexicali, and they work together with Skyworks with this specific trade. Skyworks has around 6,000 employees, Infineon has around 1,500 employees. And what is needed right now is an advanced semiconductor certification to reskill and train. So that's already set up by WTC, and also a semiconductor engineering program that starts in August of this year. So it's already been working, and as Ariel said, we've had a lot of work done, and there's still a lot of work to be done with the current companies to improve things, to advance. Because the semiconductor, and Ariel is going to agree with me here, is that in any change in sizes or change in use, it's not the same in automotive and communication. So the capital expense that goes in just to update the semiconductor factories itself is quite huge. I mean, it's not $1 million, it's a lot. So you have to have the right personnel for that specific advancement, and that's where Ariel sends the training and so on.
So thank you again, and thank you Tijuana EDC members for being here. This wouldn't be possible without your support. and we'll see you again in 2 months.